Good morning, good afternoon, good evening, everyone. And welcome to this industrial panel on the future of modern imaging, run as part of the IEEE 22nd International Workshop on Multimedia Signal Processing. We are obviously in Tampere, and this panel is streamed over Yle's virtual studio operated by our friends from Keho Interactive. Then imaging. At a doctoral training school, I heard a lecturer, a neuroscientist, saying that almost 90% of information entering the brain is visual. I'm not precisely sure about the percentage, but it was around this. And neurons devoted to vision are more than neurons devoted to all other senses combined. So it is about visual information, and imaging is what helps us to see what we cannot, like tissues in our bodies, or galaxies far, far away, or occluded objects. Imaging is what helps humans and machines to navigate, to communicate, and to make informed decisions. It also entertain and support creativity. And by imaging, I mean video as well. Imaging is a sacral word in Tampere. From the times when the first Nokia camera phone was designed here, to the unbeaten quality of 808 PureView, to the times when skillful engineers were trained in Tampere University of Technology and the University of Tampere, and scientific excellency was built. But then the behemoth Nokia lost his crown. For a while there was Microsoft Mobile, and then it was like what? Like falling. However, the community managed to make lemonade out of the lemon of these changing business opportunities. And today, along with new Nokia, we have a number of other global players and innovative startups clustered together in what we call Tampere Imaging Ecosystem. So it is my pleasure to introduce our panelists today. You have seen their names and titles, but once more, Martti Ilmuniemi from Huawei, Jarno Taskanen from Xiaomi, Igor Kurkio from Nokia, and Juhala Karhu from Axon. A friend of mine actually noticed that all Finns today are with foreign companies, and the only representative of Nokia today is an Italian. But this is what makes also the charm of our local community. I asked the panelists to prepare and to give some opening statements, something about their imaging passion, or something in the radar of their companies, important and challenging enough to be further researched. And then we'll pick questions. So I have listed some of those, and I'm sure there will be more coming from the audience. So please, send your questions to the chat window of the Zoom meeting. I will be filtering them and asking the panelists in the studio. By the way, if you are experiencing problems with live streaming over Zoom, you can also watch this panel over YouTube. It is being streamed in the CIVIT YouTube channel. someone will type the address in the chat window. However, questions can be received only through the Zoom chat window. And here we start. Martti, please.
Thank you, Atanas. Hello, I'm Martti Ilmoniemi from Huawei, and I'll discuss a little bit of challenges in mobile imaging. And first of all, the camera, that remains still one key mobile device purchase drivers. And there's a strong competition in image and video quality. And one thing that has been evolving in last years is the camera count. In last 5 years, we have gone from a single camera to 4 cameras, plus there's additional sensors like depth sensing and multispectrum sensors as well. Zooming capabilities are increasing, and also computer vision use cases, they are increasing in the way that there's some more cameras all the time. From processing power point of view, there's increase all the time. There's more power, and more powerful algorithms can be used with software and also with AI. 5G is enabling more cloud processing in the future as well. And as the processing power is increasing, there's also a new opportunities to design the hardware and the processing together. So the computer vision is also driving a new hardware innovations. There's a depth sensing and 3D. Also, something is coming that beyond the human eye. So we are not able to perceive all the spectrum, but the new sensors are able to do that. In event cameras, for example, they are capturing the fast motions, and there's a lot of innovations and driving to new hardware. So what are the challenges then? The different fields are merging all the time. Few years ago, we thought that the processing tasks are more or less separated, but today they are merging through the utilization of machine learning. For example, image processing and the computer vision tasks. Currently they are solved together. More cameras bring more data, and requirement is that we need to have more processing power. We have computational photography aspects, like multi-frame and multi-camera fusion from different types of sensors. This is becoming a standard, or already is a standard in mobile devices in photography. But how about videos? That requires a lot of processing power. Also, we can separate algorithms or combine algorithms together. What is the best combination? AI capabilities are increasing. We have seen a lot of examples of image classification, scene recognition, object detection, and segmentation, also replacing the hardware ISP blocks with CNNs. So AI will bring new opportunities as well. As a recap, the mobile imaging, that is still a rapidly developing field, and there's a lot of opportunities to innovate. And AI, that will be one of the key things which is changing the imaging from what it used to be.
Thank you. next opening statement.
Thank you. Hello. So the topic that I selected for this panel is the enablers for product feasible machine learning. Mobile imaging, so there are a lot of different use cases for mobile imaging, but image quality improvements are largely still driven by the photography and videography use cases. And in this domain of image and video quality, in terms of noise and motion blur, there's a lot of room to improve still. That has been researched already for decades, but it's still not done work. And then in the color side, color reproduction, for example, the estimations of the illumination color, that's still an unsolved problem as well. And there is also a lot of room to improve in the dynamic range and so on. So there are still many things to improve in the image and video quality. And one way to approach this problem is to add more information content to solve these problems. And that's what you can see in the modern mobile devices. So there are camera hardware improvements, multi-frame instead of single frame. Multiple cameras are nowadays available and could be utilized for computational photography and merging data from multiple sources. Then there are some additional technologies. For example, PDF recently that was introduced in the main imaging sensor that brought a big improvement in the autofocus speed, for example. And there are ambient light sensor and time of flight and so on utilized in the mobile devices. And so that's one way to address this problem. And the other way is, of course, to continue improving the algorithms further and further. I mean, often there is, you can see that there is more and more effort needed to get less and less visible improvements. But every once in a while there is a breakthrough which brings a bigger improvement. And recently, deep learning is one of such things. And this kind of comes to my topic. So what is then needed to make machine learning product feasible? So one thing is that the data sets that are used and then the reality. So there is a difference in many cases. One thing is the data coverage. So if you are talking about static scenes, it's very laborious to cover the real use cases with the dataset. And then moving to temporal transitions within those scenes, it becomes even more laborious. So it's order of magnitude more difficult. And as far as I have seen, it even looks like the difficulties in the accumulating data, it's actually also impacting the research topics a little bit. For example, in computational color constancy, the realistic mixed illumination to make a ground truth data for that kind of scenes, it's very difficult. And you can see from the published papers that there is much more single light source research out there compared to realistic mixed illumination. And then in terms of the ground truth, it's one thing to annotate for the classification problems versus regression tasks. For example, the computational color constancy is an example of the regression tasks. And then if the ground truth is subjective instead of objective, then it's also adding one layer of difficulty in the preparing the data. For example, if you want to make a ground truth about the chromaticity of the illumination, that's more easy to establish because it's an objective metrics. But then if you talk about tone mapping of an image that has a big subjective component in it, and that makes establishing the ground truth much harder. So all of these, it's causing problems for the supervised learning. So then different ways how to do this in an unsupervised way, or maybe combine both of those. That's one thing that still needs more research. And then besides the data coverage, so we also need different ways to deal with the shortcomings of the training data. And in the area of ability to generalize better based on less data, I think this is one area where we will probably see hopefully even some breakthroughs in the future, because that will make a big difference to many use cases. If we are able to generalize well with an order of magnitude less data, that would be a big thing. And the other thing which will help a lot in terms of making the machine learning product feasible is to be able to determine the confidence level or uncertainty of the results that the DeepNet or some other machine learning system is giving. So because this will allow in the productization to combine the learning-based methods with the conventional approaches. And this is one way how it's being done currently, but there is still a lot of improvement needed in these areas of research. That was the product feasible machine learning.
Okay, thank you. Before going to the next presentation, a technical message. So, as we are streaming over Zoom and YouTube, it seems that there is a kind of trial sound in the Zoom streaming, which is not present in YouTube. So people are complaining, those who are on Zoom. So we'll try to fix this, but meanwhile you might want to follow the YouTube streaming where there is no sound. Just connect to a Civit channel. I will type shortly the link in the chat window, and hopefully we'll fix this. We are a multimedia conference, so all demos have to show all problems we might have. But now it's Igor's turn.
Thank you. Hello, everyone around the world. My name is Igor Kurcho. I'm from Nokia Technologies, Finland, and I'm also serving as a convener of an ISO working group on MPEG technical requirements. Today, I have a few minutes to say something about standardization landscape in the media area, especially in the video area. So I'll touch a couple of standardization bodies where I'm actually operating. One is the MPEG, which is the working the committee that has been defining all the main video coding standards, and now recently in July it has been finalizing the latest video codec, very fresh. It's called the Versatile Video Coding, and the encoded name is also H.266, which will be then coming to all televisions and then services in the coming future. The idea for this new codec was to reduce the bit rate for comparable quality. So it will have a 50% of the bit rate compared to previous video codecs like HEVC, which is of course a great innovation, but also other features like 8K for increased resolution, high dynamic range, wide color gamut, and also it is very suited for immersive media. Another thing which is coming from the MPEG, and actually it has been now almost finalized, is the immersive media for compression of immersive or real or virtual larger 3D scene captured by multiple real or virtual cameras. Essentially, here we are coming into the multi-camera area, especially for inside-out content. This is enabling a set of new use cases like 6 degrees of freedom, navigation, and especially for virtual reality. And one more thing is an example of the standardization products for the MPEG committee is the video-based point cloud compression standard. And it is suited for volumetric video representation. And this is especially for augmented reality applications. So we will see more and more of augmented reality objects which may be coming into our scenes, pretty much like what we see today in our virtual studio in Tampere, also in our phones and on our devices. This is the roadmap. So what MPEG is doing right now and also what's coming into the future. So just to give a snapshot of the 5 years from 2020 until 2025 in different areas of the MPEG, in the media coding area, in the systems and tools, and also beyond media. And you can see that the industry is moving slowly towards using machine learning also for the next version of the VVC encoder, but also there are other codecs that are under development. For example, video coding for machines, which are technologies for video that are used and seen not by humans but by machines. So all of these are examples of how the industry is moving and then what the standards are doing in the coming years for serving the industry. The second standardization organization that I would like to touch is the 3GPP, which is the entity that develops the standards, like the 5G standard for mobile phones, mobile devices. So that's a very important organization there. And there is a group there, which is called SA4. It's the codec working group, which is the group that develops the codecs, audio and video. And there are several activities that are in the context of this organization. I picked a few of them, and here there are some code names, but the first one is about virtual reality capability, which is developed on top of a conversational low delay video with spatial audio. Then there are activities for finalizing and developing a new 5G streaming architecture and protocols. There are activities for streaming and edge processing. And there is also work on augmented reality, which is growing more and more. And needless to say that 8K is now coming more to our devices. And then, as a last, there is a framework for live uplink streaming, for example, very well suited for drones and personal broadcasting. So this is a snapshot of the activities that are in the standards. And I'll give now the turn to Juha. Thank you.
So, hello, my name is Juha Alakarhu. I work in a company called Axon. And maybe the Axon name is not so well known in this imaging industry at least, but you probably know our products. So the most well-known product from Axon is the Taser conducted energy weapon. Overall, we develop solutions for law enforcement. We have lots of solutions, including hardware, software, cloud-based solutions. And my team here in Tampere, we are working in the imaging and video. So we are developing cameras that police officers would wear, for example, in their chest or in their eyeglasses or in the car. And I can just briefly introduce some of the specific problems we have in this field now. So this is a typical example of a frame captured from a police officer video. So you can see that it's not very high quality artistic frame, but the important thing in this video is always the evidential quality. So how can we generate video? How can we generate evidence that is as true to life as possible? We don't like artistic colors. We don't like artistic processing. We just want to present the situation as it really happened when it was recorded. So the evidential quality is the other most important thing in the video quality when we are developing these cameras. And for example, in this example, the question might be, what is this man carrying in his hand? Is it a gun or something else? And you can also see that the situation is kind of rough, so there is a kind of a movement, so maybe the officer was running and this camera was shaking when he was wearing it in his chest, and you can see that there are compression artifacts, and so it's a kind of a challenging situation. So regarding the compression, we have petabytes and petabytes of data, and whatever we can do in the standardization, clever guys in the MPEG video encoding standards, please invent us smaller file sizes. So it's immediately helping a lot. Quite often we are capturing a lot of videos and then we upload them up the cloud, and the bandwidth may be quite limited, and the video file size might be really quite big. So it's immediately helping quite a bit. And if we even without changing the standard itself, the question is like, is there a way for us to pre-process the data or use these codecs in a better way so that they will give us a better quality without increasing the video file sizes? The next topic is power consumption. So the body camera, for example, would need to be on the whole 12-hour shift the officer is wearing it. And the camera is recording continuously. So we have a ring buffer up to 2 minutes, and it's continuously recording. And when the officer starts the recording by pressing the button here, then we start the active recording and we take the contents of the ring buffer also. But the important thing is that this camera is on all the time, and the smaller power consumption we have, the smaller devices we can build, less heavy, lighter weight, because we can use smaller batteries. And this is quite often limiting our capabilities, for example, in terms of like a software algorithm. So we can't implement heavy algorithms in our devices, usually in software, or then we need to be really clever so that we can avoid this power consumption dilemma. The next topic is then talking about a camera versus human visual system. So our primary target is, of course, to capture evidence that is true to life. But the secondary question is, can we also estimate from the video what the officer was really able to see? So we know that human eye, human visual system are really different from digital cameras. Human eye is only watching one object at a time. We don't record the same way as the camera, wide field of view, simultaneously. So is there a way for us to mimic the human eye behavior in digital cameras? Another interesting topic is low light performance. Traditionally, we have been thinking that traditionally the wearable cameras, especially those recording video, have been way worse than human eye in terms of low light performance. But actually some recent innovations and things we have implemented also in Axon have enabled us to get pretty close to the actual human eye limits in terms of low light performance. And that has led to another type of question: what if the camera is more than the human eye? And it creates this kind of a dilemma of the human eye versus camera recorded evidence. So it's kind of an interesting thing. Can we mimic the human eye in terms of low light performance? Then, of course, this whole question of camera versus visual system has these topics of how do people remember things versus how we store the evidence to this digital content, and would there be a way for us to implement cameras in the future that would actually help officers to see more, see better, help them to make better decisions? So overall, this of course opens door for lots of really interesting research topic altogether. Thank you.
Thank you. Thank you very much. So we are ready to start our discussion. Actually, I will start with a question directly from the audience, and because it was related with what you are just saying. It is about another company also based in Tampere, Polite. What is the cooperation among Tampere vendors and company like? Can you comment on the limitations of VCM and the need to move to alternatives like TLens?
Yes, excellent question. Well, I'm also involved in Polite, so I may not be completely objective. But like, so one of the challenge in the cameras that the police officers wear is, of course, that it's extremely heavy duty environment, and the camera might be shaking, and the officer might be running, and typically this kind of VCM actuator is not feasible for that kind of application, so it's not stable enough when there's a lot of shaking, and for example, at least in our use cases, we can't use VCM at the moment, so it would need to be something similar to, for example, Polite, if you would implement AF.
And from a smartphone point of view, there is of course also the matter of image quality. So the quick lens movement does enable use cases, but at the same time we cannot sacrifice on the image and video quality side.
Okay, maybe we'll return to the image quality a bit later. So now a related question, how to improve actually the image quality on the sensor side? Is the solution to add more sensors? Like we are seeing time of flight, we are seeing different optics like wide optics or telephoto, or is it more to develop computational algorithms, or how do you see the balance between these two?
I think it's a combination of having different sensors, different lenses, and also the computational algorithms together.
Yeah, from the device point of view, it would be nice if you could get all the quality from a single camera. But as I mentioned in the presentation, if you cannot solve it all computationally, then other ways that you add more information to the problem.
But where do you see the challenge? Is it more now? Is it like if we have the computational algorithms, we can add these sensors, or is it how to process information from different sensors, or how to design the sensors themselves?
I think in the computational problem, of course, there are then new challenges when you merge the data from multiple sensors. So there's artifacts typically, and minimizing those artifacts, that's one vector of improvements. But there is research, of course, ongoing also in the hardware all the time, and we are gladly taking all the advances from that side.
Okay.
So maybe I can also comment. So I think this kind of traditional Bayer image sensors are they have been evolving like huge amount during the last 20 years. But currently we have quantum efficiencies that are quite close to 100, like I think 80% with the backside illuminated sensors. The spectral response is really, really good. So I think there's only so much you can do with this traditional Bayer approach. So of course the question is, can we start stacking the color filters, or like stacking the color sensing? And then there are, of course, all these new innovations coming in the sensor side, like event-based sensors, time of flight, things like that. But like maybe just the traditional Bayer linear, evolution, it's coming kind of to its maximum.
Yeah, then there is this black silicon things where it's over 100% quantum efficiency.
You would still have the photon shot noise that is kind of representing the amount of photons you are sensing. So it's not still truly a noise level of that would match like more than 100% quantum efficiency. But anyway, yeah, it's of course there is of course innovations also in that.
When are we going to see implantable imaging devices?
think in terms of visually impaired people, there is already some early solutions, and I guess that would be the area where those would be first seen. So people who have lost their eye, I think improving the resolution of those cameras, I think that would be very interesting.
But no time horizon, or is it
I totally
companies?
agree, like these people who have a blindness or things like that. That might happen quite soon. And I remember, like when I started in Nokia 15 years ago, we met some research guys who were developing curved image sensors so that you would replace your retina. I don't know what the guys are currently doing, but but I hope that for those applications we would see things like that quite soon. But that kind of thing becoming a true consumer application, that will take forever. Oh, not forever, but long.
Can you, each of you, can you give your own definition of image quality? Like, what would you focus on?
I think it's clarity and naturalness of the image. So details and good colors, natural and good colors.
Aren't they always oversaturated to like impress you on current?
Not always. It's also depending on the situation and the scene. So not always. You don't need to oversaturate the colors, for example.
Okay, Jarno?
Yeah, same thing as Martti said, and so all the texture acutance and sharpness of the edges, lack of artifacts. So processing artifacts is one thing that I hate personally a lot, because that really kills the naturalness of the image. So no digital look in that sense, and the colors, of course, and brightness reproduction. That's one tricky topic, especially when you try to squeeze more dynamic range into the lower dynamic range media. So how to still keep the naturalness of the image and not make it this kind of what I call HDR look. I think in the area of HDR there is a lot of room to improve.
That looks amazing. HDR look.
But how
It
much,
makes it art.
and how much dynamic range you can actually put to a lower dynamic range display. So there's a lot of...
Yeah.
Igor?
Well, as I've been working for a few years already on immersive media, image quality for me is also how good I can see through a head-mounted display or through AR glasses. So in that case, I really would like to have a sharp image, a sharp video, enough high number of pixels per degree, so that I do not see the artifacts of the devices. So that would be a good image quality in that area.
So immersive effect to be maintained.
Yes, yes.
And avoiding artifacts. So
yes,
I guess
absolutely.
you're the two extreme cases of image quality with Juha. Let's see his.
So for our daily work, I guess the biggest challenges we currently see in law enforcement is actually the compression, the video compression, because we can't use really high bandwidth. But for me, in my personal life, as a hobby, I'm really missing still being able to reproduce natural bokeh with these handheld small devices and whatever technologies there have been to create SLR-like look in terms of image quality with these smartphones. To me, they all look really, really far from what I would like to have. So
okay,
that's one thing where you guys need to improve.
Questions from Laura Ribeiro. How do you evaluate how closely your developed police officer cameras matched human vision?
Yeah, so that's one of the key challenges I have, and like I said, traditionally, for example, in terms of low light performance, the cameras have been really far behind. But now we have, for example, Action Body 3, it matches human low light vision quite well before it has fully adapted. Then we match the, for example, the field of view and lots of things. This is one of the key areas we are working on. But of course, we can't currently match, for example, the pixels per degree, because that would create really big, huge video files. I think it would be like probably 8K for 160-degree field of view, so it's a bit too much. And then we can't still mimic the way human is watching one object at a time, but the camera is always recording everything. That's not the way humans behave.
But isn't that a good thing also?
Oh, of course it's a good thing, but there is always this question also the other way around. Is this video showing more than the officer would have seen in the situation? That might create sometimes confusing situation. Yeah, but of course, in principle, the most important thing is that we just capture as much as possible.
What actually happened?
Yeah.
Okay, thank you. And then 2 questions to Martti, to Huawei. This year, from Yuan Gao, this year Apple added a brand new DTOF sensor, D time of flight, into the rear camera system of the new iPad Pro, and probably will do the same for the upcoming iPhone. Huawei's current flagship has an iTOF sensor used to create professional level bokeh effects. Will Huawei also adopt the new DTOF sensors in the future? First question. Considering the disparity and depth can also be calculated from a stereo camera setup, are these low resolution depth sensors like iTOF, DTOF important components for the flagship smartphone?
Okay, that's the first question. I think that's to be seen, and we are all the time evaluating different technologies. So that's to be seen whether Huawei is going to implement a different type of TOF sensor into a device. I cannot maybe comment that in more deeply on that.
Then about stereo and...
Yes,
yeah.
In stereo versus the
low resolution depth maps from
yes.
time of flight.
If you have a stereo camera, you always have 2 cameras, and you always have some degree of error on the measurements. Of course, there's also on TOF there's noise and so on, and the parallax and so
and many things in the productization, the calibration is kind of a big problem area, not just for this, but in general.
Yeah, so if I have to develop professional-looking bokeh effect, should I take stereo, or assisted stereo, or time of flight as an assisting modality for getting the depth?
Well, it also depends where you are capturing. If you are outside, maybe the time of flight sensor is not giving you the depth in information, and therefore in those cases you can use the stereo camera information. But indoors it might be opposite. So those are actually supporting each other.
Complementary in a sense.
Yes.
Yeah. Okay. Thanks. We are back with questions for about quality, and actually this one maybe goes to Igor. From Emanuele Palma. Since it has been mentioned, modern imaging, new resolutions, transfer speeds, I wanted to ask what is the opinion of the panelists about the trade-off between image quality and image compression, focusing on making such detailed media available on commercial devices in the future. So because you are advertising also these standardization efforts, which are always toward image quality, but this trade-off?
This trade-off is the typical trade-off of people who are working in a standardization area. Do I want to have more quality, and then how many bits do I have to spend? So this is the typical trade-off. How much does it cost to have some compression ratio, which is saving a lot of bits. And now, like I have presented in the few slides that I had, the new standard, the VVC standard, is aiming at promising a target of 50% bitrate reduction compared to the previous generation video codec that was H.265. It means that for the same quality, the same visual quality, only 50% of the bits will be allocated to that video stream, which is it's a considerable step ahead. It means that we can either deliver the same quality for the same number of bits, or a better quality with less bits.
A second question from Emanuele, a related one. What about subjective experiments paradigms, like during the implementation of this new type of media? So how do you actually approach the question of subjective evaluation and subjective quality?
Now, in particular, what we have been facing when running subjective assessment tests for immersive media, it was the difficulty of having a new methodology. So how to do this assessment when people are watching 360-degree video, for example. They are not just watching a 80 degrees field of view, just a picture in the whole entirety, but they are watching a picture or a video everywhere. So one of the problems is how to compare different people that are watching perhaps not the same thing at the same time. So one of the issues is, for example, finding right metrics in order to make a comparable watching sessions of a person A against the person B.
Okay.
Is it mostly based on subjective or objective testing?
There are both subjective and objective, yes.
Question to Juha. Let me read it. Are deep learning police warning technologies used now, or possibly under development?
So I think that's of course like a big overall topic of ethics of the kind of all the technologies we are developing in Axon, and Axon has been actually putting a lot of effort developing ethical technologies. We are currently, for example, not using face recognition at all because it's not reliable enough. It's not something that we could use in our application, and Axon has this for example, ethics board, who is always just commenting that there's kind of ethical questions in the technology we are developing. So,
would you rely on artificial intelligence, for example, to recognize a weapon or something?
At the moment, it's not just good enough. Like, it's just simply not good enough. So, yeah, I think that's the kind of a simple answer at the moment. I don't know how it's going to be in 20 years.
Actually, a question related with deep learning, like it was touched by Jarno's statement, but what is really driving this always attempts to make everything through neural networks? Like for example, I got one of our paper rejected because the reviewer said, "Why are you not doing this with neural networks?" Like the approach mattered, not the results. And is it really is the future or a hype? So how do you see it?
Yeah, for us it's the results that matters. So for us it's one tool next to the others, but the fact is that for some of the areas the deep learning is giving the best results, and it's mainly then how we can leverage it in the actual product so that it will work anywhere in the world. So not just in the limits of some database, but really anywhere in the world.
Yeah, I agree, Jarno, as well. So the image quality and video quality is the driving thing. So whatever technologies there are, you should have the best quality. And currently, I think the neural networks and machine learning is the tool for that.
Yeah, in many of the areas there is already decades of research in the conventional side, and there has been kind of less and less improvements coming every year. So I think one big reason is that now with the deep learning there is still a lot of things to research and a lot of things to improve, and I think that's one of the driving things.
What about implementations? Like, can you have them on mobile phones?
Yes.
Yes. We have NPUs in devices which we are capable of running neural networks and CNNs on devices.
Have you guys been able to get good result in terms of like a core pixel pipeline, like this basic ISP, demosaic, noise filtering, tone mapping? Like I can imagine that machine learning techniques are really good when you need to recognize things and like do scene detection, detect this is a cat or something. But like in the core pipeline, that has been really like studied so long time. How do you see that?
I wouldn't use it for the whole pipeline because some of the things can be characterized very efficiently, like color shading and those things. But then for some things, like when you are trying to determine that how is the actual image detail going here, so often the conventional methods they are producing certain artifacts which are looking unnatural, and getting from the unnatural looking details into natural looking, it can help in those areas.
And especially these joint kind of approaches where you jointly denoise and demosaic, making super resolution. That's difficult with these kind of conventional methods, but with deep learning you can get much higher quality.
Yeah. And besides the NPUs, so one area how you can also, or one way how you can enable them in the product is to utilize this kind of parallel processing, so that you don't need usually full frame rate for all of these computations, and that will allow you to spread the compute over multiple frames.
Okay. One of my own questions, because we are kind of slowly approaching the end of this panel, because I'm the workshop chair, I can overrule the schedule, so we can get a bit longer, especially if there are interesting questions from the audience. But one of my questions was, what should we teach students in imaging? Like maybe we can start with Igor.
Well, I think there should be for sure basic courses in image compression, video compression, and then I think that some elements of artificial intelligence. I think that would be good because this is somehow showing the trend of the next years. But there is also another thing which I think it's important in order to prepare the students for the jobs. Also giving some system level skills, like all the transport protocols, you know, the packet, the formats, all the streaming protocols. These are quite important to be also injected into the courses of the university.
Anything to add?
I can say two things: optics and programming. That will take you a long way. but like I also think like the guys who are best in their field usually have somehow their own hobby projects and things they are really truly interested in also outside the professional. So it would be like if you have like a pet project that you can run beside your studies and develop your own thing, whatever it is, that's usually really useful.
I would also maybe add one thing, that this kind of camera technology is not taught in many places. So there's a signal processing courses, image processing courses, machine learning itself, optics itself, but not the whole line of camera technology.
Anything to add?
Yeah, I agree with what was said. So when you are passionate about something, it will show in the results. So if you are doing it not just to pass the courses, but you are really producing something to show that makes a difference. And maybe one thing that I have noticed also is that especially on the people who really don't have those pet projects, that there is a big difference between doing well in the studies versus doing well in the industry. Because in the industry it's about solving problems and not about memorizing things and passing courses. So adopting this mindset already in the studies, so that will be beneficial.
There is an addition to this question about multimedia security. Do you have anything specific to add? Yeah, or it was just a suggestion to mention it as a topic coming from Hajer Galbic Sahi. Yeah, so I think you are not getting dizzy because we are rotating all the time. Or
the hair is staying.
Yeah. Okay. Maybe a final question, and this is what I usually like to end up with. Can you mention the next big thing according to you in imaging? So it can be either like something that you would like to see or something that it's very challenging, and if solved, it will make really a breakthrough or disruption. Who wants to start?
Well, for me, if there is an order of magnitude less data needed to get good generalization ability, so that kind of advances in the machine learning side, I think that will enable a lot of new use cases, because currently with the current technologies, it cannot be applied in many of the problems, because it might work in a certain test set, but if we cannot trust that it will work anywhere in the world in any illumination conditions and with any kind of image contents and any kind of temporal transitions, so we might not be able to use it currently.
Okay.
Maybe I can mention that on my side, the photography is already high quality, and there's small steps coming all the time. But the video capturing, there's still a lot of room to improve. So in photography, we are using multiple of frames and multiple of cameras all the time. But in video capturing, usually it's done only by a single camera, and a lot of processing power is needed.
Well, also an interesting question could have been, what was the previous big thing in imaging? I don't know if you would have the same answer. I think that the previous big thing in imaging was the kind of smartphone and the miniaturization, and it was driven by image processing, multi-frame, optics, and image sensor. I have a feeling that the kind of basic just capturing images will not be the next big thing in next 10, 20 years. I think it will be more in these cameras that can see rather than capture. So they really understand or are able to represent what's really in these things surrounding the camera, and I think that will be driven by many different industries: automotive, security, those kind of things.
Automotive would have been a good addition.
So I think in high level it is cameras that can see
and understand.
Yeah.
So immersive media for extended reality, as now there are more and more coming devices with capabilities of optics for augmented reality. So this is slowly coming forward, and then views with 360 degrees, and then superimposing information, objects, overlays on top of the reality. This is what's coming next.
So, but is this the future? So we wear VR glasses and we are like
Yeah,
Perhaps just simple glasses, very small, very light. And it's very recent that there has been some cooperation agreement between a traditional company, that is technology company, and then a very big company that is doing glasses, traditional, and they are now working together. This just was an announcement a few days ago, so I think this kind of new products will be coming in the future.
Yeah. And with the automated driving and all the smartness that it will require, I think this photography and videography will still remain. So people will still want to store memories of their child growing up and that kind of things. I don't think that part will go away.
Okay, yeah. We saw creativity in the beginning, like there was some animal, like to illustrate the entertaining power of imaging. So, okay, but thank you very much. I think it was an interesting panel. It was a bit of bumpy start, so like the audience was getting some additional sounds. So next time we have to make it audio visual to discuss also challenging in audio when combined with video. And yes, so thank you once again, and good luck to all your research teams, and looking forward to future research collaboration. Thank you very much.
Thank you.
Thank you. And now we are back to the schedule of the workshop. Thank you to the audience for asking interesting questions. Please stay active and do the same with the next speakers. Thank you.